Assalamu alaikum dear viewers, Shoaib Ahmed is here, and today's lecture is related to the transformer operation. In the previous lecture I have given you the little bit concept regarding the your transformer, what is the working of transformer and what was the construction of transformer. The transformer is an electrical piece of equipment which is used to raise or lower the amount of the voltage with the corresponding decrease and increase in the current values. Okay, and it has the two windings as you can see from the diagram, the primary winding and the secondary winding. The primary winding is connected with the source side and secondary winding is connected with the load side. Okay, now let's start to discuss the operation of the principle of operation of transformer, that how transformer works. Okay, so the principle of operation of a transformer is based on the mutual inductance between the two coils wound on a same laminated magnetic core. As you can see the diagram of the transformer, there are the two coils. They have the magnetically coupled, but electrically both coils are isolated. Okay, so our first coil, which is called the primary coil, is connected with the source side, and secondary coil, which is the second coil, is connected with the load side. Now working. When an alternating voltage is applied to the primary, okay, as you can see, we are applying an alternating voltage to the primary winding of the your transformer. What happened? An alternating flux phi is set up in the core. Now, if this is the core of the transformer and you are applying the alternating voltage to this primary winding of the transformer, the core is magnetized. When the core is magnetized, what happened? Your magnetic flux is being induced, okay, in the core. This alternating flux linking both windings and induced e.m.f.s E1 and primary in the primary side and E2 in the secondary side. Okay, as you can see from the diagram, V1 we are applying to the primary winding of the transformer, and what happened, the E1 is induced in the primary winding of the transformer, which is called the induced EMF produced in the primary winding. And this type of the induction process is called as a self-induction, because here the coil property changes its your magnetic flux with its own self. That will be called the self-induction. What about the mutual induction here? Obviously the magnetic lines are coupled to each other, both coils. The phi is already set up because you are applying the electrical your AC supply to the primary winding, and what happened, induced EMF due to the magnetic linkage to another winding which is called the secondary winding, and what happened, E2 is induced in the secondary winding of the transformer. It is because of the mutual induction, which we have already discussed in our previous lecture, that in the mutual induction process we are supply the voltage to coil A, and induced EMF will be produced in the second coil B. Here's the same one is the process is to be done over here. The E1 is produced in the your primary winding of the transformer, and E2 is induced because of the magnetically coupling between the two coils, the primary and the secondary coil, and due to the flux linkages between the two coils, the E2 will be produced in the secondary winding of the transformer. Okay, now according to the Faraday's law of electromagnetic induction, EMF E1 is termed as the primary EMF and E2 is termed as the secondary EMF. Okay, now what is the Faraday's law? Whenever a flux is linking with the coil is changes and EMF is induced in the coil. So this is the main theoretical concepts regarding the Faraday's law of electromagnetic induction, which we have already covered in our previous lectures of the electrical machines. Okay, now the magnitude of the E1 and E2 is totally depends upon E2 is totally depends upon the number of the turns of the primary coil and the secondary winding. Okay, now induced EMF, which is produced in the N1 winding, okay, and induced EMF which is produced in the N2 winding is totally depend upon the number of the turns of the coil on the both sides. E1 is which is produced in the primary winding is totally depend upon N1 number of the turns on the primary side, and E2 which is produced in the secondary winding of the transformer is totally depend upon the number of the turns on the secondary side, because according to the Faraday's law of electromagnetic induction, MMF will be greater when you are increasing either the number of the turns of the winding of the coil or either increasing the d phi over dt within the coil. Means d phi over dt, rate of change of flux with respect to the time. If you are increasing, again EMF will be more induced in the coil. So if N2 greater than N1, V2 greater than V1, or induced EMF when your secondary side is greater than E2 greater than E1, whatever this type of the transformer is called is the step up transformer. And if N2 less than N1, V2 less than V1, okay, and E2 less than E1, so this type of transformer is called as step down transformer. Okay. Now if the load is connected on the secondary winding and your secondary EMF will cause the current to be flow from the secondary winding of the transformer. If you are connecting any kind of the impedance and the load, then load current will start flowing from the windings of the transformer. Okay. So some of so at the last, thus the transformer enables us to transfer the AC power from one circuit to another circuit with the change in the voltage level. Okay. So in the case of the step up transformer, your output voltage will be greater in comparison to that input voltage, and in the case of the step down transformer, your output voltage is less than your applied voltage. So here the AC power is to be transferred from one circuit to another circuit, but with the change in the voltage level on the both sides. Okay. The following points may be noted to summarize the whole discussion of the operation of the transformer. The following points should be noted. So let's discuss the following points. The transformer action is based on the laws of electromagnetic induction. Means here we are going to verify the two laws. The Faraday's law, which is called as means whenever a flux is linking with the coil is changes and EMF is induced in coil. And second is that your Lenz's law, because here in the induced EMF on the secondary side is totally opposite to that primary side of the EMF, and that will be opposite to that applied voltage. According to the Lenz's law, the direction of the induced EMF, the direction of the secondary side EMF will be opposite to that primary side your voltage, so applied voltage. So this will be called as the Lenz's law, which is the EMF will be induced in the secondary side will be because of that cause of the primary side magnetic flux. Okay. And second thing, there is no any electrical connection between the primary and the secondary. So AC power is to be transferred from primary to the secondary point only just because of the magnetic flux. As you can see, the primary winding and the secondary winding, you can see there is no any electrical connection between these two coils, but both coils are magnetically coupled. So due to the magnetic linkages, magnetic flux linkages, the power is to be transferred from one circuit to another circuit, from one side to another side. There is no change in the frequency. Output power has the same frequency as that of the input power. There is no change in the frequency. On the primary side, either they have the step down transformer or the step up transformer. Either they have the higher voltage or the lower voltage. On the both sides, your frequency is the same one as the standard frequency. Like in our Pakistan, if we are talking about the Pakistan frequency, power system frequency, it is a 50 Hertz. If we are using the step down transformer, if we are taking the example of a step down transformer, if it is going to step down the value of that 132 kV to the 11 kV. So from the 132 kV line, from the 132 kV side, the frequency is the 50 Hertz. And here on the 11 kV side, the frequency is the same 50 Hertz, but the power is to be the different one. Okay. Last point is that the losses which are occur in the transformer are that there are the two types of the losses. Core losses. Core losses are the sum of the AD current losses plus hysteresis losses. If we are just going to elaborate these two losses, like AD currents means when your core is connecting with any kind of the AC supply, the core is magnetized, and small amount of the currents which are produced in the core to magnetize the core, circulating currents. So that are called as the eddy currents. If eddy currents are more in the core, what happened? The core will be more heated and efficiency of electrical machine will be reduced. So to decrease the eddy current losses, we have to laminate the core into the several parts to minimize the effect of the eddy current losses, and hence the heat will be reduced and efficiency of the electrical machine will be increased. And second is the hysteresis loss. If I am going to recall the concepts of the hysteresis law in the basic electrical engineering again, hysteresis loss is that the hysteresis effect is that the phenomena of the flux density lagging behind the cycle of the magnetization is called as the hysteresis. But hysteresis loss is totally depend upon the magnetic material which type of the magnetic material we are using. Normally the electrical machines are designed with the low hysteresis loss, with the low magnetic hysteresis effect, like your silicon steel, which have the low hysteresis loss, and this type of the material is the ferromagnetic material. Okay, and what is the hysteresis effect in the machine? Means if we are going to magnetize the one piece of coil, okay, so and second the first piece is that means the coil is to be magnetized in the one direction and energy is to be expended to change the coil polarity into the other direction. What happened? The energy which is to be expended over that coil to change its direction from one side to another side, so some energy has been expended in the form of heat. So this will be called as the hysteresis loss, hysteresis effect. So it totally depends upon the material. If you are using the low hysteresis material, magnetic material, ferromagnetic material, obviously this loss can be reduced. And second is that your copper losses, that are the resistance in the winding. So if you are connecting any kind of the load with your transformer or any electrical machine, what happened? The load current will starts flowing from the windings of the your coil, like here in the secondary side. So it totally depend upon the current, load current. Copper losses depend upon the load. So load currents are greater, then copper losses will be greater. So this was, dear viewers, this was today's lecture regarding the transformer operation. And I hope that you have understood today's lecture, which was very interesting one, the transformer working, construction, and again I am going to repeat all these things in today's lecture. And at the last, please don't forget to subscribe my YouTube channel Shoaib for more informative videos related to the electrical engineering area. Thank you.